Okay, ladies and gentlemen, thank you very much indeed. It's my great pleasure to introduce our third seminar speaker of the Modern History of Mathematics series. And our speaker today is Professor Caroline Ehrhardt from Université Paris 8, and she will be speaking to us on calculating prodigies in the 19th century, science as spectacle or real arithmetical skill. Thank you, Caroline.
Thank you very much, and thank you for the organizers to have invited me here. It's really enjoy being here with all the people I don't see so often at the same time, so that's very great. And I want to apologize because, as you may guess, I won't speak about Veblen. So it's totally different, but still. So let's start. On November 16, 1840, a somewhat unusual event took place at the meeting of the Paris Académie des Sciences. A young boy named Henri Mondeux was introduced to the academicians to demonstrate some computational procedures he used to perform to do complex arithmetic operations on large or very large numbers. He did it very quickly in his head. The Academy took the phenomena sufficiently seriously to appoint 5 of its members, including the 4 mathematicians, François Arago, Charles Sturm, Joseph Liouville, and Augustin Louis, to investigate it. A report was drawn up and read out at the meetings of December 14. Mondeux, then 14 years old, was what we call now a calculating prodigy or mental calculator. He was born into a poor family and had never attended school. He was sent by his father to work as a shepherd in a farm near the city of Tours. And Émile Jacobi, headmaster of a nearby primary school, heard about him and set about teaching him. The boy's extraordinary gifts soon aroused curiosity in the region. His arithmetical skills were demonstrated in public performances, first at the Mentor's House and then at several high schools. And thus, on the strength of the young prodigy's regional reputation, and after having met Arago, who was deputy historian in France, Mondeux and Jacobi traveled to Paris, and in the fall of 1814, they were admitted to this session of the Academy. Mondeux was not the first calculating prodigy to attract the attention of the real world. In 1814, the young 10 years old American Zara Colborne was examined by the Bureau des Longitudes in Paris and the Royal Society. In 1837, the Sicilian shepherd Vito Mangianelli had been examined by the Académie des Sciences, and by the similar examination was done by the Académie des Sciences in Madrid. Mondeux would not be either the last one. In 1845, it would be Ferdinand Colonzeux, John's studying at Paris Science. In 1846, on the other side of the Atlantic, it would be the American Academy of Art and Science that examined Truman Sappho on the initiative of Benjamin Peirce. And then, in the second half of the 19th century, Charles Grandemange, Jacques Inaudive, and Péricles Diamandis would also be in contact with the Paris Académie des Sciences. Like Mondeux, these individuals interested scientists from both a mathematical standpoint and from a medical standpoint. And like Mondeux, they had passed through the doors of learned institutions after acquiring quite a celebrity within the general public. So some calculating prodigies have been the subject of math history papers, but as far as I say, the subject as a whole has not attracted much interest. And I must say that at first glance, it may seem anecdotal and not very serious. Although exceptional mental arithmetical skills are often mentioned in biographies of mathematicians like Ampère, Gauss, and John, for instance, they are more the stuff of legend or anecdote or the construction of genius than something that had to be taken seriously. It has to be said also that I guess that since the beginning of the 20th century, the the computational prowess is not necessarily how we define the mathematician. And once more, the practice of arithmetic is readily regarded today as something like boring, automatic, and tedious. So, and therefore, the opposite to creativity and intuition, we sometimes or very often consider to be the hallmarks of great genius in mathematics. And yet, as we have just seen, the path of many of these prodigies calculators actually intersected with the Academy of Science and scientific circles. Interest in the method they used led some of them to the Academy, to the laboratories, and in other words, the phenomenon was not so anecdotal in the 19th century. And it seems to me that it was because it touched to a question that was ultimately important, that of the concrete practice of calculation. How to become more efficient? What brain function does it mobilize? But also in the background, what characterizes a mathematician? What makes him or her, mostly him, with me? And another reason for my interest in these calculating prodigies is that they are one of the few examples where mathematics has really caught on with the public. Prodigies belong to the world of circuses and were part of the amusing sciences in vogue in the 19th century. This issue has received considerable historiographical attention within the past decade, mainly, I guess, in the context of human science and history of colonizations, for instance. I've listed a few references, mainly in French, but I guess not a lot of other ones. And of course, the case of the calculating prodigies is certainly not as tragic as that of the resented Venus or human Zeus, but however, the attention paid to them by the public, and indeed by certain scientists, is due to how different they were from the world around them. And yet, again, the interest of scientists for calculating prodigies cannot be dissociated from what is it about, namely the practice of calculation, understood in the time in the sense of numeracy. So from that point of view, the history of calculating prodigies at the time is a question also linked to the history of education. So during the 19th century, this young boy found themselves at the crossroads of three worlds. The world of entertainment, where the skills or jumping numbers were admired. The world of brain, studies of brain, and of course, finally, the world of metaphysics. So let's go back to Mondeux. After his stint at the Academy, Henri Mondeux spent a few months becoming the darling of the salon in Paris, of the Paris elite. He was invited to the homes of scholars, he met writers, he met diplomats, he met noblemen, he met prominent artists, including Georges Sand and Alfred Vigny. Vigny even dedicated one of his poems to him. I'm sorry I didn't translate it because given my low-level English and English poetry, it would have been quite disrespectful to him. Mondeux performed in show venues intended for privileged audiences, such as the Salle Ehrhardt in Paris in March 1841, where he took part for 60 francs, which is quite bad, at a concert at La Sylphide, where 2,000 people were there. He then toured in private educational institutions. He toured also in several collèges royaux, which were high schools, in Paris. And then, during the year 1841, he began an itinerant life and performed in French province and abroad. It is a life that can be followed nearly day to day in the daily and journal press in France and elsewhere. And for several years, we can say that Mondeux was quite a celebrity in Europe. However, although he pursued a career as an entertainer through all his adult life, and until his death in 1861, the success he has enjoyed in his early years did not last long. Audiences eventually tired of him, and many press article reports at the end of the 1840s, I would say, they say that nearly nobody could reach. By 1855, in the work of his mentor, Emile Jacobi, he had already been almost forgotten. However, on the other hand, the success of these calculating prodigies as a phenomenon proved far less ephemeral and circumscribed than the fame of Ehrhardt. One indication of the popularity of this phenomenon is that from accessible sources as digitalized newspapers and magazines, it's very easy to compile a list of prodigious calculators who were born in the 19th century. More generally, it's relatively easy to find information, including portraits, on these calculators. And it's easier than finding portraits of many mathematicians in the life to know how they looked. The reason for that is that this phenomenon took place at a particular time when the public showed a great taste and curiosity for science and technology. So through the Western world, calculating prodigy were to be found in theaters, infant fairs, where amusing physics experiments intersected with sleight of hand and even spiritualism sometimes. In France, the craze for calculators seems to have begun in the 1820s, maybe 1830s, but it was probably earlier in Great Britain. Vera Corbon, the American boy, he toured in Europe in the 1810s. He even bet William Royal Hamilton, then a teenager, during a arithmetical contest in Turin. He did not enjoy a great success in Paris, but he was in Paris in 1814, 1815, which was kind of political complaint because of the revolution, so we can understand that. If we now go into the 1820s, in Great Britain, a boy called George Parker Bede was exhibited at fairs under the nickname calculating board. I even found the trace of a girl, one girl called the calculating girl. Her name was Elizabeth Haywood, but she left very few traces. And at the same time as Mondo was filling the Parisian salon, a young German called Zacharias Days was enjoying similar fame in Germany, in Austria. He even came to London. Shortly afterward, we have Charles Grandemans, was also selling frequently. He was exhibited in Freak Show. And in the United States, I found a William Street Hutchins, who worked at Barnum American Museum in the 60s under the name Lightning. Finally, at the end of the 18th century, Sicilian-born Jacques Inodi enjoyed a real major international career in cabaret, notably becoming one of the attractions of the Théâtre Robert Houdin in Paris, for the big stuff, and in the Folies Bergère in Paris. So what these calculators had in common was that they received very considerable attention from the public. Their shows were performed in a variety of venues, as I said, private saloons, public spaces of entertainment, schools, many other places. And so, for the reason, it is fair to say that they attracted interest from different strata of society. And this craze involved really quite a large audience. Another thing they had in common was that their performance received a fair amount of media coverage. And yet, however, few traces of these performances survived beyond the statement of the question presented to the Prodigies. To set up for this performance were similar, I guess. The setup for all these performances were more or less similar for all mental calculators. Members of the public would pose problems with answers why they had already calculated in advance, and then the prodigy would solve them on the spot. In the vast majority of cases, in fact, these problems presented no real mathematical difficulty, since they were formulated by people who themselves has very little knowledge of the discipline. For example, Henri Mondeux was asked to calculate how many letters there were in a library of 1,529 volumes. Each volume had 617 pages, each page had 29 lines, and each line 35 letters. The answer is wrong. I don't know. There was a mistake in the drawing. More rarely, audience members posed algebraic questions or problems, but then they evolved far less impressive numbers. For example, Beater was asked to find a number whose square multiplied by its fourth may produce 432. And Monde was asked how long a legal argument would last if the lawyer could use no more than 10 different words, but could always change the order of the same words in every possible way and pronounce 20 words per minute. And then he answered 126 days after Africa. So, as these examples show, the spectacular nature of the show stemmed less from the theoretical complexity of the question than far from the fact that the calculator performed all the operation mentally without ever writing anything down, and it was also from his or her ability to respond very quickly, even when the numbers were very low. But as with any live show, the audience attractions also lay in the staging and the person being put on show. So the contrast between the prodigy skills on the one hand and his lack of education and youth on the other made his performances exceptional in the eye of the audience. Thus, for instance, the repartees of which Monde, he was very young, was capable, his naivety, his touching modesty, as Sugerman expressed it, his excessive candor, also moved the spectators and charmed the lady. Similarly, the physical manifestation of concentration, which could fade, the physical manifestation of concentration linked to calculation was visible in Aristotle's posture, the brightness of his eyes, the contraction of the features, and that struck the audience. In the case of Elizabeth Highwood, conversely, it was the fact that an interruption does not disarrange her mental calculations that would surprise people. So, in the eye of the public, there was an almost supernatural quality to the figure of the prodigy. It was perceived as a gift, and all the more so because calculators were discovered when they were very young. What's more, insofar as is something innate, for which calculator had invented their own methods and procedures, it could be perceived as a form of intelligence. And one of the mainsprings of the public interest in calculators was, in fact, that there was a big contrast, real or perceived, between their mental capacities and their social or physical characteristics. Indeed, at a time when the study of mental and cognitive faculties was still in infancy, arithmetic prowess was often spontaneously associated with another form of distinction, which was this time social or cultural. I would say it would be distinction, culture, instruction in a war of education. And it was partly because this prodigious calculator clashed with the prejudice of the time that they were considered prodigies at the first place. Some, like Monde or Mangiamale in her early days, were uneducated and lacking good manners, which was in fact linked to their very modest origins. The press extolled the fact that when this young shepherd who had never been to school were better than scholars in arithmetic, other calculators, more objectively speaking, suffer from different kind of infirmities or diseases, just as, for instance, one of them was blind. Or, presently, according to the description given in the press, they had problems such as autistic disorders, or epileptic, or something like that. So all these problems in the 19th century were supposed to be incompatible with the superior exercise of reason represented by calculation. At the end of the 19th century, the key to Inaudit's success and longevity lay in the stage designed to accentuate quasi-supernatural nature of the performance. Inodi stood arms folded, staring out at the audience, and at his back to a blackboard where his impresario who recorded the problem. And behind the impresario, you had calculators performing the calculation by hand in writing. And during the lapse of time, Inodi took that advantage to solve other small problems posed by the audience. In the same way, he enhanced his show in the traditional codes of the cabaret. For instance, he wore a suit that's slightly illusionist or magicians. He called on assistants, but also he introduced sometimes novelties, such at the time when he undertook to perform his show from a lion's neck cage. Yeah, I would have loved to find a picture, but unfortunately, that is apparently no. So, more generally, if people were interested in the shows of calculating prodigies, it was also because the audience found them something they know, something that related to their own experience of mathematics. Actually, the way a prodigy is perceived is partly linked to the level of mathematical training of the audience. If you don't know what a cube root is, or if you have not struggled with big numbers by yourself, you can't see what's exceptional about calculating it by hand. And on the same way, if you have never made a mistake while calculating in your head, you can see what is exceptional. So the question of presence, competent man who would appreciate the value of the prodigy was therefore an important condition to the success. But what was exactly this mathematical competence? As we have seen, the questions posed by the audience during the show were mostly limited to primary and elementary education. The vast majority were concerned with elementary arithmetic, sometimes logarithm, but not from the point of view of calculus, from the point of view of calculating tool, and more rarely with root expressions or sometimes solving equations. In the same way, we know from Jacobi's biography that Mulder's reputation in Tours was based on his ability to carry out operations related to commercial transactions. So this operation may have been seen very simple to a cultivative Parisian public, but in Tours it could be to find the people could find it impossible or very difficult for the surrounding farmers. During the 19th century, arithmetic and calculation because the basis of elementary education in math, and more profession required rapid calculation skills. However, in the 19th century, from what I've been able to read, for instance, in French newspapers, reports of Inspector for Teachers or administrative guides, mathematics was already perceived as difficult. And it was particularly the case in secondary schools, where the other part of the teaching was essentially literature. So the craze for calculating prodigies took advantage of the population's growing acculturation to mathematics, linked to the development of mathematical instruction and literacy in all strata of society. And indeed, the performance by calculating prodigies were based on a balance between the spectators' recognition of the difficulty of the exercise in which the prodigy was engaged, and the comparison between his performance and that the spectator could do by himself. So, beyond the sensational, the audience found in this show practices and knowledge that referred to their own experience of mathematics, but also potentially enabled them to improve it. And indeed, an important aspect of the public interest was the reproducibility of the method for educational purposes. In a context where knowing how to calculate had become a valuable skill for growing numbers of professions, and where practical arithmetic and mental calculation manuals were multiplying, the method invented by the calculators, which were supposed to be both original and time-saving, were being taught and published. and were proving marketable beyond the world of life performance. This explains why part of the Prodigies presented was directly aimed at students. A particularly sought after venue for performances was that of educational institutions. In the same way, articles on the calculating Prodigies can be found in the youth and educational press. The aim was to surprise pupils, but also to arouse their curiosity and interest. Monde, for instance, was invited by many heads of institutions with the aim to provide pupils with a useful distraction and a remarkable example of superior talents united in a child barely arrived at an age where one begins to study studies. Teachers saw his presence as an opportunity to interest pupils in the practice of arithmetic, to encourage pupils to prepare and solve questions. But Monde's performances were also seen as a means of maintaining motivations by showing to what point of superiority one can arrive by stubborn work. And since Monde's teacher, Mr. Jacobi, never ceased to repeat that work alone develops the happy disposition of his young mathematician. And actually, Jacobi's insistence on modern education served a dual purpose. On the one hand, this enabled so-called teacher to legitimize his presence at the child's side and to justify the income he earned from the latter's performance. And on the other hand, it also enabled Jacobi to develop a second business activity also based on the gift of his protégé. For instance, settled in Marseille in 1951, Jacobi set up a course for accountants, teaching arithmetic according to the method used by his pupils, at a cost of 10 francs for 8 sessions, which he advertised at the end of Monde's performance. Jacobi also published a number of books with same names in the 50s, at the time when, I already said, the public get tired of Monde. And these books included, I won't list, Algorithmia in Italian, other one called Caractère de divisibilité des nombres, divisibility of numbers, another one with many treatises of mental calculation, and so on. I would say that from that, Jacobi published, had a very, I would say, lucrative line, publishing books from his proximity with Monde. Here again, Jacobi was neither the first nor the last to reveal or attempt to put down on paper this exceptional procedure that the public had been able to see for themselves. We also read in the Quarterly Journal of Literature, Science and the Arts that George Bidder and Vera Campbell have been offered to disclose their method on condition that they be remunerated in a respectable manner. The latter actually published his method in his memoir, which, as indicated in the title, include 10 pages on his particular methods of calculation. Method that it is said that Hamilton studied closely and which aroused his interest in mathematics. And the other one, for Bidder, who became a railroad engineer, he published several years later in an address appearing in the minutes of the procedure of the proceeding of the institution of civil engineers. He published quite an explanation of his methods. And in doing so, Bidder intended in particular to demonstrate that, as it can be quoted, but I don't sure you can read it, mental arithmetic can be taught as easily, if not even with greater facility, than ordinary arithmetics, and that it may be rendered conducive to more useful purposes than that of teaching by rule, that it may be taught in such a way as to strengthen the reasoning powers of the youthful mind. Similarly, in France, Grandemans was awarded to the silver medal of the Société pour l'instruction élémentaire for his ingenious procedures for mental calculation. He wrote a book about it. And in 1863, Grandemans also published a book entitled Arithmétique théorique, pratique et mentale, theoretical and practical and not arithmetic, with a collection of 600 exercises and problems coming with it. Hutchins also published this book called The Lightning Calculator, in which he explained the method he used during the shows. So, while it is difficult to know what the impact of such statements and the success of it books were, that publication at least shows that interest in calculating prodigies in the 19th century went beyond the entertainment or amusement provided by the performances, and it included improvement that could be made to the teaching of the discipline, and beyond that, to the practice of arithmetic itself. And I guess that it was precisely for that reason that the prodigies were taken so seriously by the academic institutions at the time. So it is easy to understand why calculating prodigies and their mentors sought to make themselves known to scholars. Because, as I have funny quotation on that, the prodigy is, at the academy, the prodigy is noted, the tests undergone are cited, and the report that the commission in charge of the examination becomes a magnificent prospectus. So, of course, the examination of the Académie des Sciences provided a certificate of authenticity for the calculator's gift, warranting against the public against deception. But why, conversely, were the mathematicians of the Académie des Sciences interested in the phenomenon? Since the beginning of the 20th century, it has generally been accepted that the mathematician's homework, as I already said, is not his or her computational progress. I haven't had a quote somewhere saying that Henri Poincaré said he was unable to make an addition without making a mistake. Of course, it may be true. In the 19th century, however, the boundaries between the practice of mathematics and that of calculation was much less clear out. Calculation by hand was an important part of the mathematical activity, including learned mathematical activities. Think, for example, of obtaining numerical values for the solution of numerical equations in mathematical physics, the operation of astronomical observation, or the creation of numerical tables. In France, the first expression of this interest in calculating prodigy that I found at the Academy was 1837. It was Vito Mangiamale who had been recommended by François Arago, by a professor at the Faculté des Sciences of Lyon, and Arago offered to test him by asking him a few questions before deciding whether or not to make a report. The test having proved conclusive, a commission was appointed, including Lacroix, Majority, Sturm, Louis, and Arago himself. Reason for it came apparent in 1840 when Mondé came in, because actually Mangiamale's mentor had clearly not agreed to reveal the young prodigy's methods to the academy, whereas Mondé master accepted. Furthermore, the calculating prodigy were supposed to be naturally gifted in calculation, which was a characteristic that sometimes attributed to mathematicians. For instance, and this feature was very often given. For instance, the Dirac-Colburn's memory for numbers was compared to that of Euler. Mangiamale and Mondé were compared to Pascal, and they led their contemporaries to wonder whether these children could also contribute to the development of the mathematical science. Could they become mathematicians? So the curiosity of scientists for that reason overlapped with the public's curiosity about processes and methods. Mathematicians wanted to know whether the calculation mechanism employed by the prodigy was similar to procedures already known, or whether they were genuinely new and faster or more easy. So in his report to the Académie des Sciences about Monde, Cauchy mentions an artifice worth noting to explain how Monde solved two simultaneous equations of the first degree. So he explained that to do this, he subtracted the two equations from each other after multiplying the first by a ratio between the sum for successively for one and the other with the coefficients of the two unknowns. With a slight modification of this procedure, we could simply subtract the two given equations from each other after dividing each of them by the sum of the coefficients that affect the two unknowns in the first members. The resulting equation would then always immediately provide the difference between the two unknowns, from which, as Raymond has seen, the unknowns themselves are easily deduced. And we would thus obtain, for a solution of the two equations of the first degree, a method which would offer the advantage that the calculation would remain symmetrical in relation to the two unknowns whose values we are seeing. So I won't give the detail, you can read it, but the idea is that actually Cauchy did find something new or something unknown or something easier in the way Monde was doing. Similarly, another example is given by a method developed by Charles Grandemont to calculate the hypotenuse of a right-angled triangle with two known legs without extracting the square roots. So this method was the subject of a note in a very famous book in French, which is Éléments d'arithmétique, Pierre-Marie Bourdon. Bourdon was an examiner for the admission at the École Polytechnique and wrote several textbooks in French, quite successful at the time. He was also a member of the Royal University, Conseil Royal des Universités, which kind of Ministry of Education at the time. So to calculate the square roots of the square of 45 plus the square of 249, Bourdon explained that having obtained the quotient 4 of the division of 3,209 square of 47 by 408, the 249, we multiply, etc. That will be all of it. And after detailing a few examples, Bourdon demonstrated actually the method, noting that Grandemont's difficulty in expressing his idea in the ordinary language of science had prevented him from discovering the consideration that it may have led him. Mathematicians were also interested in the person of method calculators and or his potential. By questioning the ability of the prodigies to solve problems other than arithmetic, to understand explanation, and to develop their own ideas, scientists were basically trying to gauge their ability to practice mathematics professionally. The aim was to distinguish between the simple calculator, computer, highly impressive but limited in its abilities, and the potentially future mathematician. So in the report he wrote for the Académie des Sciences in 1814, Cauchy first emphasized the self-taught nature of Monde, who had discovered for himself methods related, for instance, to the Newton binomial formula, or even method for summing integers, such as the sum of an arithmetic progression, but also the sum of cubes, fourth, and even fifth power of natural numbers. And using example, Cauchy went on to explain how Henry has gone about solving the problems he had been given, which involve algebraic calculations of equation of degree greater than 2 and indeterminate equations. Last but not least, the academician emphasized Henry's facility not only in memorizing numerical values, but also in assimilating complex informations and procedures. For all these reasons, at the end of his report, Cauchy recommended that the government provide Jacobi with the means to develop more and more the rare faculties that give reason to hope that his extraordinary child will one day distinguish himself in the career of science. In the same way, it was not so much Henry's sample piece of calculation that led Peirce to recommend his enrollment at Harvard, but it was his early exhibition of the thirst for knowledge and his capacity to acquire it, which were accompanied with powers of abstraction and concentration rarely possessed at any age, except by minds of the highest order. If you look now, Gaston Darboux reports to the Academy of Jacques Inaudy, which was, I think I didn't put the date, it's 1892. Darboux came actually to the opposite conclusions. But he said as much about what distinguished mathematicians from calculators. Admittedly, according to Darboux, Inaudy had certainly devised the rules he applies to each of the operations, rules which differ from those taught throughout Europe in elementary schools. But for the more difficult problems, Darboux could only observe that Inaudy's procedures were simple trial and error, while regretting that at the age when Inaudy could study, he had not received the lessons of an intelligent and skillful master. Darboux, in a word, did not distinguish in Inaudy the conditions necessary to become a mathematician. Facility in calculation, certainly, but also ingenuity and, above all, a great capacity for learning. In fact, despite the hope that may have been raised, none of these calculators discussed here turned out to become mathematicians. Most, like Mondeux, Inaudy, Hutchins, remained confined to the world of entertainment, with more or less lasting political fame. Some made a career of teaching mathematics. Grandemont became teacher in Orléans, Mangiamane became teacher in a high school in Versailles, and Prolongeur became professor of preparatory classes in French, like high hierarchy, after winning a scholarship at the high school Henri IV and go to the École Normale Supérieure. A few of them took advantage of their remarkable computational skills to be paid to get work or employment. For example, Zéra Colborne worked for some time as a calculator for the official British almanac. Elizabeth Haywood contributed much, I found just a quotation, much to the support of her father and little brother by her calculation for private companies. I don't know what it was exactly. The most famous here may be Zacharias Days, who not only calculated 200 digits of pi, but also tables of logarithm, and contributed to the reduction of data collected from the triangulation of equations. A few others, however, went on to make successful careers in science. These included George Patermida, who became, as already said, a railroad engineer, quite famous engineer, and Truman Harris Seffer, who you may know because he was professor of astronomy and became director of the Hopkins Observatory at Williams College, Massachusetts. In the eyes of the public, calculating prodigies had an almost supernatural quality, and so they were perceived as an exceptional gift. But insofar as calculators invented their own procedures and methods, this gift could also be seen as a form of intelligence. And this is why mental calculation was the subject of much interest from specialists of mental phenomena. The exceptional nature of the prodigy was in fact likely to make visible phenomena that were more discrete or normal, more discrete in normal individuals, and thus to support hypotheses or even provide scientific theories, scientific proof for theories elaborated in disciplines that were at the time in the process of developing and seeking legitimacy, such as phrenology and psychology. So phrenology was founded by Franz Joseph Gall in the early 19th century. It was based on the idea that different areas of the brain perform different functions and that their development influenced the shape of the skull. So according to Gall, an individual's aptitude could therefore be detected by inspecting the shape of his or her skull. And in the first few decades of the 19th century, phrenology was defended by many scholars as a legitimate science capable of explaining cerebral aptitude and impulses. That was then totally discredited from the 1840s. So, to demonstrate the validity of his method, Gall examines the skulls of individuals with particular characteristics: criminals, politicians, musicians, but also mathematicians. And in particular, he devoted a section of the fourth volume of his book to the sense of number ratio, where he announced that he had located the ability to calculate in area at the angle between the temples and the forehead. Not to test if you have that, it's here. Yeah. I had divided actually in 37 compartments, each containing an image and representing a phrenological faculty. And calculation is number 30, next to the eye. So his obsession was based on the examination of several portraits and busts of scientists and on the cast of the school of the young mental calculator, Ehrhardt, and also on a direct observation of a young Viennese calculating prodigy. Until the 1840s, the observation of mental calculation has thus become a standard procedure for trying to give credence to that theory. As a journalist of the Journal des Débats, which is quite an important journal in France, ironically puts it in 1838, Mondiamali and Mondeux were thus examined for the same purpose by members of the Société de Phrénologie de Paris. Casts of the schools were made on these occasions and are still in the collection of the Muséum in Paris. Another example is given by Georges Combe, who was a promoter of phrenology in Scotland, who reported his encounter with another prodigy, George Parker Bidder. So he explained that when Bidder first came to Edinburgh and before had seen him, a gentleman waiting on me, accompanied by 3 boys of nearly equal age, and said, "One of one is George Bidder, the celebrated mental calculator. Can you tell me where is he by his head?" And on examining the organ of number in all of them, I replied that one of them should be decidedly deficient in arithmetical talent, that another should possess it in a considerable degree, and that the third should be bigger, because indeed the organ was developed to an extraordinary extent. So, phrenology's infatuation with calculating prodigies has left its mark on everyday language and on the popular imagination, where in France at least we have this expression math femme. We have it in French, la bosse des maths, that. So it refers in French to a particular aptitude for understanding mathematics very easily, which is supposed to be innate and independent of other mental abilities. But above all, the interest of these individuals for understanding mental faculties linked to calculation survived the discredit of phrenology, and from the 1880s onward, it was the promoters of what would become psychology who took part in this interest. So at the end of the 19th century, anatomist Paul Broca presented Jacques Inaudy, still a child, to the Société d'Anthropologie de Paris. This examination was followed on from George Gell's work on the use of mental images of numbers, which in part stemmed from a remark by George Parker Meadow Jr. George Parker is the son, actually, who had apparently inherited the gift of his father. And so George Parker Jr. told that he used to visualize number in fixed, distinctive, and spatial patterns. And in questioning Inaudy, Broca identified a phenomenon which was different from that discovered by Galton, because in Inaudy, the ability for mental arithmetic was linked to an exceptional memory of numbers, but one was essentially auditory in nature. So 12 years later, neuropsychiatric Charcot and his collaborator, psychologist Binet, examined Inaudy again, and this time to experimentally test memory function. So the test showed that Inaudy's speed was no greater than that of trained calculators performing written calculations. So there was indeed a question of memory in mental arithmetics, and Inaudy's extraordinary results were based first and foremost actually on an exceptional memory. But the tests also showed that this memory was in fact specific, since it concerned numbers and not letters, and that it was not linked to an anatomical peculiarity, as found, but to a psychological fact, notably to the combination of several mental faculties such as attention, willpower, perseverance, and for them above all, a passionate taste for the kind of studies which is in connection with this field. So these findings prompted Binet to the question of the hypothesis of gift or monstrosity, depending on how you see that, in favor to that of an ability that everyone has, more or less naturally developed, which can be improved by exercising it, but which diminishes when not worked out. The conclusion of psychologists, as you can say, made us, well, that's in line with those of Darwin at the same time, and also with the testimonies of certain calculators such as Google. So in conclusion, what do mental calculators teach us about the mathematics of the 19th century? The praise for this phenomenon testifies to mathematical, or at least arithmetical culture in a full bloom among the population, since success came from a certain conformity to the performances with arithmetical practice of every day. People read about the mathematical shows and papers, but they could compare their own children's abilities with that of the Prodigies. They also put a magnifying glass on the values associated with mathematical practice at the time, indeed the speed of execution, the use of large numbers, and above all the inventiveness of arithmetical procedures raised questions about the Prodigies' ability to become full-fledged mathematicians. And in the eyes of the public, the mechanism of calculation was largely confused with an exercise in reasoning. But there is one essential aspect that was not lost on mathematicians from Cauchy to Darwin. In their view, you could be a born calculator, but there was not such a thing as a born mathematician. Mm-hmm. Regardless of one's aptitude, the mathematical abstraction and reasoning that characterize mathematical art requires an apprenticeship and acculturation to the discipline. And this type of education, still largely reserved for the elite in the 19th century, was also what a young shepherd like Henri Monod had trouble with. At the end of the 19th century, the calculating prodigies were confronted with formidable adversaries who were also admired by the calculating machines. When the first computers, like Kasparov against Deep Blue in the 1990s, they became the last bastions of human intelligence in the face of technological progress. But these technical advances actually did not make them totally obsolete at first time in the beginning, at least in Italy. In the 1970s, the European Organization for Nuclear Research still employed a computer prodigy, well inclined to make calculations that remain too complex or time-consuming for the computer.
Thank you very much, Caroline. We have time for questions. Good luck.
Thank you, Gary. That was great. I have many questions, but perhaps one or two that are connected. Can you say a little bit more about the social makeup of the audiences for those shows that you mentioned, especially in terms of class and profession? And the reason why I'm asking that is that I was reminded of this book by Antoine Lilti on the history of fame and celebrity, and he talks about the careers of musicians like this, something that was only possible in those very decades, because they would also be traveling from private salon to private salon in spaces made possible by the rise of a bourgeoisie that had the means to support them, to create the conditions for those kinds of careers. So I was wondering if another facet of why calculated prodigies can emerge in that fashion in those decades is linked to socio-economic.
Yeah, actually, what is interesting is that you have part of that. Within the audience, you have a learned and elite audience, which is that of the salon. You have many things in Jacobi's biography explain how they came into these fancy places and modern countryside boy, I would say. So and actually, yeah, you have this part of it, and it's totally being, for instance, you often Mulder and List, they were sometimes the same kind of problem. So this is this modern, what we call modern French places. But maybe the difference with this phenomena is that it was not the only place or social space where it happens. And actually, high schools and teaching institutions were really a place where it often happens, and especially in the city in Provence, they really were linked to local learned society or local learned circle, which was not this Parisian bourgeoisie of the time. It were very more normal people, I would say, bourgeois, but not on the same way, the Balzac bourgeois, I would say. And you also had, which is maybe less visible because it's more difficult to find sources, but there were also in fun fairs and in real entertainment space. It made the Barnum Circle, of course, but it's in America, it's not necessarily the same in France, but this is also this world too, which is much more difficult to document.
Gemma, then we have a question online, but Gemma first.
Thank you so much. I also have many questions, and I won't ask them. So at the beginning of your talk, you were talking about some of the literature around like colonization, colonialism, and then at the end, you were also talking about some of these competitions between electronic calculators and people. And so, I wondered if in this research you've come across like non-Western calculating prodigies being imported into Western places as sort of a phenomenon.
The only there are, in the 18th century, you have an example of a calculating prodigy in the US, which is a black person, a slave, but in the 19th century, I haven't seen that.
I wondered also, because I know there were in the 20th century like competitions between people using an abacus versus an electronic calculator, and so
no, I haven't seen that. It was because I guess that the prodigy comes from the mental part of it, and the only mental part of it.
This is an online contributor who also has several questions, but I will pick one because it's to do with this technological link and computational aid. You noted the new 19th century context of mass education and numeracy behind attention to the phenomenon of arithmetical prodigies. And you're obviously very aware of the new technology associated with these contexts, the blackboard. The person said, I was struck by the presence of blackboards in many of the images you shared and wondered, have you found anything about the relationship between mental arithmetic and written calculation in view of the prominent place of blackboards in many of the source material?
Actually, I think that the blackboards were there so that the audience can check by himself that the prodigy was not lying. Because if you are asking to multiply two very big numbers, I mean, you cannot do, I mean, I cannot do that by myself in my head. But if somebody at the same time is showing the calculation on the blackboard, you can check that the prodigy's calculation is right.
Mm-hmm.
So that was one reason why, because ordinary people needed it to be written, because if not, they could not check.
Today, when like Arthur Benjamin in the U.S., he does these shows,
Yeah.
he gives everyone just calculators. Yeah, and so but that's they have electronic
Yeah.
calculators, but back then,
Yeah.
you had to have that.
Yeah, absolutely. Jude.
Yeah, thank you, Karen. That was really fascinating. I was just interested in sort of partly in the economics of it, because when they're giving their shows or in a fun fair, then one can see how that can work. But what about in the educational context? Why would a calculator go into a school? I mean, what are they being paid when they go into a school? And who's paying for them to do it, rather than going and giving a show where they're going to be paid?
Actually, I haven't found many sources on this question of money, which is, you're probably right, totally central on everything. But maybe they could have been paid, for instance, by the city. It could have been something else. It was not each person going to the show that would pay, but it would have been paid by the institution if it was private or something like that. But the other thing I think is that it was a kind of advertisement. It's advertising, because if you're going to the high school, then the journal will speak about you, and then you will be invited in the salon where you will get money. And being invited to the school is also a way, as I showed, to have pupils that may go to lessons that the mentor will give, or to sell books, for instance. So that was also this part of the economic logic that was at stake, I guess.
You mentioned that Jacobi came from simple background, but maybe he was Jewish. Did this play into this?
I don't know if he was Jew. Actually, he doesn't come from such a simple background. He was a teacher in a private elementary school, I would say. So he was a little educated. I really don't know. So
Okay.
I've not found anything.
And on that note, I'd very much like to thank Caroline again for her.